The next concept we're going to discuss is the idea of a complete graph. A complete graph. A complete graph uses the symbol K, a capital K and a subscript 6. The subscript 6 means that there are 6 vertices. And if you look here, this is an example of a complete graph. There are 1, 2, 3, 4, 5, 6 vertices. And in a complete graph, every single vertice is connected to every other vertex in the form of an edge. So A is connected to B, C, D, E, and F. B is connected to A, C, D, E, and F. And likewise, all the way around, each vertice is connected to every other vertex so that they're all connected and is a complete graph. So what we're going to do is make a K5, which is a complete graph with 5 vertices. So to do that, first I'm just going to make my 5 vertices. I'm going to call this A, B, C, D, E. And then I'm just going to connect every vertex to every other vertex. So A is going to connect to B, C, D, and E. B is going to connect, it's already connected to A, so connect to C, D, E. C is connected to A and B, so D and E. D is connected, so the last thing it needs to connect to E, and E is connected to every other vertice. So this would be an example of a K5, a complete graph with 5 vertices where every single vertex is connected to every other vertex in the form of an edge. Now, one thing you're going to have to do in your problem sets is find the number of edges in a complete graph. Now, the number of edges in a complete graph is denoted by this symbol using this formula. The formula is n multiplied by the quantity n minus 1 all over 2, and for kn. N denoting how many vertices are in the complete graph. So what we're going to do is we're going to find out how many edges are in this K5. So in the K5, this symbol is actually written a little bit. That 5 needs to be subscript. So then this 5, that's what n equals. So I'm going to say n equals 5. Then what we're going to do is we're just going to plug 5 into this formula to figure out how many edges are in this K5. So right here is an n, so I'm going to write 5 and then parenthesis, and then 5 minus 1 parenthesis, all over, all divided by 2. Now I'm just going to use order of operations. Order of operations, remember, parentheses, exponents, multiplication, division, and then addition and subtraction. See, we have parentheses here, so that's the operation that we're going to do first. We're going to do 5 minus 1. We're going to rewrite everything else. So I'm going to rewrite this 5. 5 times, well, 5 minus 1, what is that? That is 4 divided by 2. And then I'm going to do just the simplification, the multiplication, and the division. So 5 times 4 is 20 divided by 2. And 20 divided by 2 is 10. So that means there's 10 edges in a K5. A complete graph that has 5 vertices. Now let's practice this process one more time, but with a K6. This complete graph up here, this is a K6. So let's see how many edges are in this K6. I'm going to rewrite this symbol. It's K6 with a subscript 6. That means that n is equal to 6. So I'm going to use this formula. I'm just going to plug in 6 where there's n. So there's an n, so I'm going to put 6, parenthesis, 6 minus 1, parenthesis, all over 2. Just like the last example, we do the order of operations. Order of operations says we do parentheses first. I'm going to rewrite everything else. So we have 6 times 6 minus 1, which is 5, all over 2. From here, it's just multiplication. 6 times 5 is 30. 30 divided by 2 is equal to 15. So there are 15 edges in a K6. So in this picture here, there are 15 edges.